Morning student, I am N.V. Krishna Rao, Assistant Professor, CSC Department. I am handling the compilation course. So in the last class, we have discussed the compilers and interpreters and what its advantage, disadvantage and comparisons. Now we'll continue with our next topic. So now we'll discuss the compilation process, right? So here, what are the different steps that we use to compile the source program to target program, right? This is our diagram for the compilation process. The first one, skeletal source program. It might be one file, or two files, and multiple files. All the files are input to the preprocessor. Here, in these files, we may use a preprocessor commands. In C, C++ languages, in other so many languages, we use the preprocessor commands. What is the advantage of preprocessor commands? Here, it will reduce the task of the programmer for writing multiple times of the same statement. It works to the similar to functions, but the body of the function should be single line or two lines. What is the advantage of the function? If we want to write some same code at different places, we write in some function, we call the function every time. But when we are using the functions, the main status of the main function will be saved and control goes to the subfunction, transfer of the control to the subfunction, execution of the subfunction. It also creates a record of the subfunction and perform the execution and returns back to the main function, control, transfer. Right? So whenever we call the functions, these saving of records and transfer of controls will occur. This extra headache is reduced by preprocessor only when the function body is one or two statements. We'll see. This is one example for the preprocessor commands. Okay, we'll see one by one. So here the preprocessor command, what it says, whenever the definition, preprocessor definition is there, it will replace with its respect to preprocessor statement. Right? So here, instead of writing the two lines at multiple places, we use the single word, the preprocessor definition at all the places. Right? Before compilation, the preprocessor will replace the preprocessor definition by its statement. So, headache of writing the same lines multiple times is reduced with the help of preprocessor. And it will have the advantage of a function call. But it also reduces the headache of the functions, using of functions. Here, it's reducing the load on the compiler also by processing all the preprocessor commands before the compilation. So these are the advantages of using the preprocessor. It will combine the source code from the multiple files to a single source program by processing all the preprocessor commands. Include stdio.h, include other source programs, all are processed by preprocessor. The hash include is also the example for the preprocessor command. Right? So, the output of this preprocessor step is a complete source program. This complete source program will be the input to the compiler. This complete source program will be the input to the compiler, right? So here the source program will be converted by each phase of the compiler. It will convert one form to another form, and finally it gives to the a assembly form, machine level code form, or any other converted form, object code form. So, in generally, we consider a compiler will take a source program. It will convert the source file to all different forms by each phase of a compiler and finally gives assembly program. This assembly program will be the input to the assembler. It will be the input to the assembler, right? This assembler will convert the assembly program to relocatable machine code, right? So it will convert the assembly program to relocatable machine. Here, the meaning of relocatable machine code means the generated machine code will have the address references but not the exact address locations. It will refers to some unknown reference, right? So these files, this object code, this machine code can be moved from one place to another place, one system to another system, right? To execute this relocatable machine code, we need of linkers and loaders. Here, the task of the linker is, in the preprocessor command we said hash include stdio.h. What is that header file? This is a header file will consist the object code of the all predefined functions. So here, if for the input or for the output, whatever the functions it required, it will be used by this, will be available in this stdio.h. So object code of all such functions used for input output that are available in the stdio.h will be included to the current source program. We say string.h, all the string functions object code is directly included to our current source program object code, right? It is included to our current program object code, right? So finally we'll combine, might be if you include other source files, that also be its object code also be included with the help of a linker, right? So we get a single object code form will consist the all the header files object code. Then we need of a loader. The task of this loader is assign memory locations for all the variables, all the statements, also for the temporary variables, such that the object code will be executed perfectly by taking some input and to give some output, right? So here, what is a variable? A variable is a memory reference. So the value of the variable is stored in some memory. That memory locations are assigned by this loader. This task of this loader is assign a memory locations for all the variables or statements and temporary variables such that make that program executable to get the final absolute machine code. So this is the the complete compilation process. These are the different steps in this compilation process. So initially we'll have a skeletal source program. It might be one source file, might be multiple source files. It might be single source file, or it might be multiple source files, right? So that all the with preprocessor commands also may exist in this skeletal source program, will be the input to the preprocessor. Then what the preprocessor do? Will process all the preprocessor commands and it will combine the all the different source files to single source file and gives the output as single source program. It will be the input to the compiler. It will be the input to the compiler. Here, the compiler will convert the source program to assembly program. Here, the compiler has multiple phases. Each phase convert one form of the source program to another form. So finally, the output of the compiler is assembly program. It might be one of the forms of object code, right? This assembly program will be the input to the assembler. The task of assembler is convert these assembly programs to relocatable machine code. In assembly program, we will have the symbols, we will have the codes for representing the instructions. But machine code, everything in terms of ones and zeros. The symbols, the memory references, the register references, instruction codes, all are converted from assembly programs to machine code ones and zeros. Here, the assembler will generate relocatable machine code so that the object code can be moved from one place to another place, one location to another location, one system to another system. It cannot be executed directly. It needs a linkers and loaders. What is the task of a linker? Just now we already discussed. A linker will combine the object code of all the header files which are included in the current source program will be combined. So if we say include stdio.h, that stdio.h will consist the object code of all the input output functions. Simple printf and scanf. That function's object code is included to our current source program. If we are combined any other source programs, its object code also be here linked to our current source program, current program object code. Then we need a loader. Its a task is assign memory locations for each and every variable, for each and every statement, and for all the temporary variables such that it makes the machine code to be executed perfectly. It will take some inputs and also gives some output. So we refer it as absolute machine code, right? So here, this is the complete compilation process. So preprocessing performs operations on the source file before the compilation. This is one example for the preprocessor operation. We are defining fun function x comma y. Wherever you say fun a comma b will be replaced with the replacement statement. we define that fun as 3 into x plus y into 2 plus x. So, here that replacement statement must be a single or 2 or 3 lines. If it further it has statement, then using of functions is better than this preprocessor commands, right? So, for example, a equal to fun of a comma b. It will be replaced as a equal to 3 into a plus b into 2 plus. The preprocessor, whenever, wherever it sees the definitions, preprocessor definitions, it's replaced by its preprocessor statements. The definition by preprocessor statements, right? Such that writing the single statement or two statement all different places by the programmer headache is reduced. And this is doing before the compilation, so that headache of the compiler also reduced. And we are using the advantage of functions also. That is the advantage of preprocessor commands. So, hash include is also one of the preprocessor statement, right? So, replace that header.h with the contents of the file header.h, right? So, these are the other different preprocessor statement. Define, include, undefined, if not defined, if, else, else if, end if, other, right. These are the different preprocessor commands. All these are preceded by hash. This is an instructions to preprocessor, right? So, if some definition we doesn't know, it is defined or not defined. We say, if defined, do some task. If not defined, do some task else. If already defined, we say now undef, so that the previous definition will be removed. So we can use a fresh definition of the preprocessor definitions, right? So these are the different preprocessor commands that we use in C language, C++, or some programming languages. So now we'll see this complete compilation process once again. The programmer will take help of an editor in writing the source program. Right? For Java also there are so many editors are there. For C also there are so many editors are there. C++. So using of editor is for comfort writing of the programming statements. If you write any keyword, color will be different to find out what are the keywords. It gives all the available function names. It gives the already defined variable names, right? It makes the programmer write the statements of the program more easily, right? So, with the help of editor, a programmer will write a source program, right? It will be the input to the compiler. The compiler will convert the source program to assembly code. Then, assembler will convert this assembly code to the machine code, right? Relocatable machine code. Then, with the help of linkers and loaders, we'll get absolute machine code. Executable machine code. which have a memory references, which takes some input and executes if any errors also generated, right? Here, this will be, we control the execute with the help of a debugger. The task of the debugger is to check the execution of each statement of the program. We may sometimes we get the wrong output. No errors in the program, but output is wrong. We doesn't know where that logic problem occurred. So with the help of debugger, checking each line of the each line of the program, we can find out, we can rectify all the logic errors, right? Then till it has some errors, then once again we'll do the corrections with the help of editors. So this is a cycle for the compilation process. So what is the task of a linker? A linker combines the object code of all the files which are included in the current source program, right? If we have is library functions, other files, are different resources supplied by operating systems, all its object codes is included to current file, right? It also resolves references in each object file to external resources, reduce the declared in the other files, right? So it's a main task, combine the object code that are included in our current source file with the help of other files to the our current source code, so that all that functions will be available in our current source program. At stdio.h, include stdio.h, include strings.h, include math.h. So all that mathematical functions object code will be available in our current source program. This loader is a task is to assign a memory locations for all the variables, all the statements, also for the temporary variables, to make that relocatable machine code to be executed perfectly by taking some inputs, process them, and gives the output. In the relocatable machine code, there will be undetermined starting location. But after this loader, it will calculate appropriate absolute addresses for these memory locations and adds to the code. That is a task of the loader. So finally, it must recognize all the legal programs, and it must be generate the error messages in any wrong statements in the program. Mistakenly typed statements, giving wrong outputs, right? It must generate the correct code, right? It must recognize legal programs. It must generate the correct machine code. It must manage storage of all the variables. It must assign memory locations for all the variables. It must agree with the operating system and linker on the target forms. If we generated a executable machine code, it must support by operating systems. It must follow the machine instruction formats of the operating systems, on which machine we are executing the programs. Here, we may require some intermediate representations also to improve the object code to make it more efficient. Here, the front end maps the source program to intermediate representation, and back end will maps intermediate representation to target machine code. The complete compilation process we are divided into front end and back end. The task of the front end, the source program to be converted to intermediate representation. If we want to improvise that intermediate representation, we can optimize, we can make it more efficient. Then with the help of backend, we'll convert the intermediate representation to target machine code. So now we discuss the complete compilation process. In the next class, we'll discuss the front end, back end, and other next continuation topics. Okay. Thank you. I'm closing this section now.
Like, share and subscribe. Hit the bell icon for more updates.